I hope I'm audible. So, hello everyone. This is the NPTEL course on environmental geomechanics. It's an interactive session. Here, what we do is we discuss assignments for the previous year course for the similar course, and then we'll go through them one by one and try to solve them. And if anyone has any doubt, you can ask. So, let's proceed. So first is about okay. So this is a question on the environmental impact assessment. This is one of the first thing that's discussed in this week's lectures. So what question? The question is that to get the clearance from the Environment Authority, what we call it. So what is required to get clearance from the Environmental Authority? Now, when we look at the options, the first option is environmental impact analysis or assessment, and other three are, when I explain environmental impact analysis, you will see that other three are basically part of the environmental impact assessment. So, as the name suggests, it means to analyze the impact of any project, any civil engineering project on the environment. So, how any project that's been going on is impacting the environment, it has a different aspect to it. For example, it has a social impact, it has economic impact, and it has environmental impact. So social, because when we see whenever there is a project is being proposed, for example, let's say to build a dam, the important thing to notice is that wherever we are building a dam on a river or anywhere on a river, what is the or how many people are we displacing, or are we displacing or not displacing them? So how many people are getting affected? If we are moving people from the location to a different location, are we giving them money, or are we providing them the proper living infrastructure? If not, then why how can we move them? So all of this comes under social. Next is economic. Economic means that uh, the project that's being proposed, is it economically feasible? For example, that the what is the amount, what is the total cost, and does this cost less than the economic means the cost that is used, or that is proposed for the project, is it feasible, is it okay, or is it like for example, uh, is it the amount which basically they will is it the so as we know that there are tenders that's been submitted for different project, right? So cost means that which person is providing good material at lesser price, so that also has an impact. Another is environment. It means that whatever the project is, how it is impacting the environment. For example, if we are building a dam, how it is impacting the soil in the area. Does building a dam will increase the chance of flood or not? Or how is it impacting the vegetation? Or the amount of pollution it will generate? All of this comes under the environmental impact analysis. So whenever we are starting a project, we need to get clearance from the environmental authority, because any project has impact on different aspect of human lives, and that is what comes under the environmental impact analysis. Now the next question is about the contaminant concentration. So it's a very simple question, that if a groundwater is stationary or in a moving state, how the contaminant concentration differ, or in which case it is higher. So let's take example of a lake. So when we look at a lake, lake is a stagnant or a stationary water body, right? And when we look at river, river is a moving water body. In both of these cases, if let's say a lake is not properly taken care of, what will happen? There will be algal growth, and sometimes this growth is so much that the life, uh, the fish and plants under the lake will die, and then it contaminate the water. And other things, what other things can happen? The nearby, so people start dumping their waste in the lake or near the lake. So all of this, what will do? It basically contaminate the lake, and because it's a stationary water body, things will concentrate, they will not move. When it comes to river, which is a moving water body, what will happen? That there is uh, there is first, even if there is an algal growth on the surrounding, okay, let's say on the walls or on the boundary of river, even if there is algal growth on the boundary, what will happen? Because it's a moving water, it will not stay permanently, it will remove. So there is no point of the marine life affecting, and hence there is no contamination. Another thing is waste. So even if it's a river, people do dump their waste in the river, but what happen is, because it's flowing, it will take it with him. So if you dump your waste here, or if there is algal growth here, because of its moving nature, it will take it to another place or to another place. So in a moving water, or in a moving state, there is no concentration or no concentration of contaminants. It is a similar case in groundwater. So if groundwater is stationary, what will happen? All of these, whatever is leaching from the surface to the ground, or whatever contaminants are already present, they will concentrate, and in the moving state, they will move from one location to the another location. So answer is yes, they are higher in a stationary groundwater compared to a moving groundwater. Now, the next question is about the spread of contaminants. So, which of these method is effective? Now, we go through these methods one by one and see how they are important, or they can prevent the spread of contaminants. So, first is curtains or cut-off walls. So, as the name suggests, it means that uh, there is a boundary around the waste. So what happened in some places? So let's say this is a land area, this is soil, and this is a landfill site. Okay, so people are dumping waste here. What cutoff wall can be is that they make an area around this, which basically is made of impervious material. So what impervious means? Impervious materials mean that it will not let anything go or leach from here to here. So they make a sort of a curtain or a wall around the landfill site, or a contaminant, which makes it hard for it to leach down the soil and contaminate the groundwater, right? Another is grouts. So grouts are basically a mixture of water, cement, right, and clay. So what grout means that in a let's see, this is soil, this is groundwater. Now, if here you are dumping your waste, and if the soil is fractured means there is a lot of cracks in the soil. So what grouts, one of the method of grout is that you will fill these fractures with this material, this material, which makes it impervious, so that the contaminants will not flow from the disposal site to the near about area and to the groundwater. So again, it is also can help in the prevention of spread. The last is the permeable reactive barriers. So this figure suggests, so this wall is the PRB, or the permeable reactive barrier. So what they are, it's basically a wall made of material which which either absorb, they either absorb the contaminant or react with it, uh, make less harmful substance, right? So this or either yeah or either they bind themselves with the wall. So this PRB is made of a material so that if there is any leaching happening from the landfill or the waste disposal site, and it is mixing with the groundwater, so this is the water table, there is groundwater here. If it is mixing with the groundwater and you make a barrier between the contaminated groundwater, so what this PRB does is, it is made of material which actually either the for example, this has heavy metals, so these heavy metals would react with the material of this PRB and make something very which is less harmful. Or either it will the particles are such that this contaminant will stick to the particle of the layer and will not move further. So what it does, it helps in removing the toxic contaminants from the water. Hence, this diagram suggests that from the contaminated water, after going through PRB, it is moving. It becomes a treated water or a less harmful groundwater. So all of these methods actually help in the prevention of spread. Hence, the answer is all of the above. Now let's uh, let's see the. Hanji. Yes, बोलिए. Yeah, yeah. It okay. It absorb the contaminant as well as it can absorb. It depends on the type of material used. So one of the important thing is it has to be clay, right? And right, another could be a any microbial wall, because microbe can also help in degradation of these compounds. Um, I cannot I could not get the example for the absorbing, but I can tell you in the next class what other material can there be. Yeah, yeah. So okay. So now let's move to the next question. So it is about the. It's a very simple question about the geomaterial alteration. Right. So we know in the last session I have discussed about the geomaterials. So they are anything which is naturally formed in the earth, like soil and rock, or either they could be artificial, for example the construction waste, or the byproduct, or the industrial waste. All of this comes under the geomaterial. Now the question is that which of this does not alter the geomaterial. So to discuss this, let's take a very simple example. So we all have seen houses, which is like the houses where no one lives and no one is taking proper care of. So when we look at in the on the terrace of that house, there are walls, right? Or on that house, the walls are basically we see they are green, generally green. So that is because of what? Algal growth. Another thing is that the outside walls are always in contact with what? Rain and sun, right? So this is, the walls are made of cement, right? So cement and algae is what? A biological material. Rain has different types of gases dissolved in it as well. For example, sulfate, nitrate, all these gases could be dissolved in it. Sun is a source of thermal energy, right? So these walls have impact of algae, which is a biological material, have impact of rain and sun. And when you, after a prolonged period of time, when you go and touch this wall, or when you try to break them, they are so fragile that you can break them with hands. Because this, what does this algae does? It stick to the wall. It start the disintegration of the particle of the cement or the wall. What rain does, again it has mild acids, right? Mild HNO3, mild sulfuric acid. It will react with the wall. Sun, it, there is constant period of cold and hot. So in the night there is, sorry, so in the night there is cold, and during the day there is very high temperature, right? So this constant process of hot and cold, what it leads to, it leads to cracks. So these three different sources, a biological as well as a chemical and a thermal source, leads to okay, एक second. Uh, okay, sure. Now can you see? So all these, yeah, so all of these different uh, sources or different agents are leading to the alteration of geomaterial. So the answer is that all of these leads to, an answer is none of the above. The similar question is the agriculture activity. So agriculture activity, what comes under it? For example, you can, okay, wait. Uh, you cannot see. Now you can see. Okay, 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 okay. Yeah, okay. So another question is about the agriculture activity. So agriculture activity, for example, harvesting, plowing the soil, all of this comes under agriculture activity. So these are the different interactions that's been given. So it's same. So soil and chemical, for example, fertilizer. So we use fertilizers and they actually impact, can have both positive and negative impact on the soil. Bacterial, because bacterial can have a symbiotic relationship. Symbiotic means that they provide nutrient to the soil, and hence and living in, to the root of the plant, and living in the and plant is providing them nutrient, like that. So symbiotic means both are getting benefited. So bacteria can live in a symbiotic relationship in the soil. And thermal again, because of heat, sun. So these, all of these, again, these interactions are given in a agriculture field. So again, answer is again this one, that this, uh, all of these interactions are visible and happen regularly in a agriculture field. Now, next, we move to the next question. It's about, okay, so it's about the, okay, why, what is the purpose of growing vegetation on a disposal site? So first we need to know that why, what is the importance of plant. So plant has two part, right? One is shoot, another is root. So this is, if this is the land, or this is the boundary, the below part is root and the upper part is called shoot. So when we study deforestation, we understand the importance of root. What root does is, root is basically help in binding of soil. So it bind the soil particle, and hence reduce the slipping. Okay, so if this is a land, and this is, uh, let's say, for now, let's see, this is a slope. And if you grow, if there is no plant here, what happen during rain, or during any sort of displacement, this soil will come down. That is one of the reason of landslides as well, that because there is no binding force, so soil is loose, and everything, if because of any sort of jerk or anything, the soil comes down very rapidly. Now on the other hand, if there is plant, what they do is, their roots bind with the soil particle. Hence, even if there is, if there is, let's say, a shock, the it will not let it move for a long distance. So the soil will shake, but it will not move, and hence there will be no landslide. So we look at, with a similar perspective, let's look at the disposal side. Simple, uh, if you are from West Bengal, you know, dhapa, right? So there is, uh, there are landfill sites. These are basically large mound of waste. Now, if there is no vegetation, so any sort of activity, let's say there is nearby construction happening, lot of big instruments are hammering into the soil, it will come down. Okay, because shock, it it will slip, and hence again, if there are people, or if there are houses nearby, it will affect it. So on the other hand, simply if there are plant, what it do is, it bind to its particle, and hence reduce the slippage of waste. So this mountain will stay mountain for a long period of time because of the vegetation that's growing. So the purpose of plant is to stabilize, so that it will not move from its location a lot, and hence affect the people or anything nearby. Now, other two points, for example, the oxygen concentration or removal of odor, all of this actually a plus point. So, if you put plants in any area, they will help in removing the odor, or they will increase the oxygen concentration because they take CO2. But that is not the primary reason for the growing vegetation. The primary reason is the stabilization of waste. Okay. Next is about the water table. So first, what is water table? In a very simple definition is that a boundary below which soil is saturated with water. That is called water table. So anything above it, even if there is water above it, so above water we call this is a Vado zone. It is basically unsaturated zone. Unsaturated means that there is water present, but it but all the grains, all the pores are not filled with water. Below water table, everything, all the pores is filled with water. It's permeable, and there is, if we put a borewell on it, we can take out water. That is what you mean by saturated zone. So if we have a shallow water table, so this is a diagram, this is a river, and here this is a water table in this area. Now if we look at the distance from the land to the water table, it's different. Here it is higher, and here it's less. So let's say we are considering this region where the water table is shallow. Now, if I have to deposit or if I have to dump my waste here, what would be the best method? Right. So, first is deep disposal. Deep disposal means that you dispose the waste very down, like in the very depth. Now, if you do that, let's say you deposit below the water table, and the water, let's say here, and you make a concrete wall around it so that it will not come out at all. But with time, what will happen with the constant action of water? There is a very high chance that the water will slip inside, or there is a breakage in the wall because of water action, because water can also act as a weathering agent. So if it weathers the wall of of this boundary of the waste, what will happen is eventually this waste will mix with the water. So for a shallow water table, deep disposal is not a right method. Next comes the surface stacking. It means that here you make a region, and then you keep on piling waste after waste over it until it make a heap. We wait it here. So you can do it, because what will happen is, not here, so I draw it on the water table. So this is the surface, right? On the surface you make a heap of uh, waste. So in surface stacking, if you make a, the boundary which we studied in the previous question, if we make a cut off wall over the over this region, it will reduce the chance of leaching. So it reduces the chance of leaching to the water surface. So surface stacking could be a good method. Next is near surface disposal. So near surface disposal means that here you make similar thing. You make a trench, you dispose the waste, you make the wall. Again the same thing happen, that with time it will start leaching. Now the difference between these two is the distance. So if it is a surface stacking and you are making a wall, the distance is much larger compared to when you are doing the near surface disposal. Now there is another thing that in the lectures it's been discussed is about the attenuation. So soil has this property that it can decrease the amount of contaminant that is going top to bottom, right? So because of the attenuation of soil, the time or the it will take to leach from surface to the water table, or from the deep under the surface to the water table is differ. So it will take more time for this compared to this. So this is also not a good method. We'll discuss attenuation in the next question itself. Right. So for this question, surface stacking is a better method, because in this method we give waste more time and reduce its leaching to the groundwater. Um, okay. So the next question is about the saturation. So what do we understand when we say saturation? So saturation, if we say for the water, is when all the grains or all the pores are completely filled with water. That is saturation. It means that uh, that area or that geomaterial is saturated. So it is a function of depth. Why? Because the deeper it is, there is a higher chance it is closer to water table. So in the previous figure, we see that this is water table, this is Vado zone, and this is saturated zone. Here the particles are saturated, but the deeper it is, there is more saturation. So it's a function of depth. Another is location of water table. Definitely, if it is uh, so the particles near the water table, the saturation level near the water table is less compared to at the depth. So it's the same case with the shallow aquifers. So so saturation is also a function of where the water table is. And another is the material property. Definitely, because we know that porosity is about the number of pores, and permeability is about the connectedness. So a material which has high porosity and high permeability, for example, what? Sand, right? Gravel, which has high number of pores and these pores are connected. These material act as good aquifers, or they actually leads to more saturated, they are highly saturated compared to what? Clay. Why? Because clay is porous, so clay has high porosity, so but it has low permeability. So clay is not a good aquifer. So hence all three property actually impact the saturation. So this is what I was talking about, the attenuation. So attenuation is when the soil does not let the contaminants reach to the bottom. So what it does, it stop the migration, it reduces the intensity. High sorption capacity, again, sometimes what soil does is it absorb the some of the heavy metals on the surface itself. So if the soil, so it again depends on the type of soil. So for this type, what we need a soil with no pores basically, and no permeability, or very less porosity and very less permeability. Because even if there is leaching, what will happen if there are no pores? It cannot seep down. And if there are pores but they are not connected, again it will not let let it go to the groundwater. So uh, the type of soil that we select, or the type of soil that is used for the attenuation of waste, is a very low porosity, low permeability soil. So what it does is, because of its low porosity permeability, it will not let the waste reach deep down. Even if it can go down, it will go in a very limited amount. And because of high sorption capacity, the particles or the grains will absorb the heavy metal on itself, and hence it will not let it leach to the groundwater. So that is one of the quality of a soil as well. Okay. So last is this question is very easy. So this is something that is in the first slide of this week, about the genesis of environmental geomechanics. So why we need to study environmental geomechanics? First, because again there is lot of population, people need a place to stay, and they want to stay in a better environment, in a less polluted environment. So we need to understand how to make um, we need to how to plan an area so that large number of people can live and with less damage to the environment. Industrialization, because if people are there, they need food, they need job. So a lot of industries are there. Industries are lead to waste. So, as an environmental geomechanics, you need to understand that what type of waste or byproduct is generated, how you can utilize this waste. So, the 4 R's that's been discussed in the lectures are reduce, reuse, recycle, uh, and refuse. So, reduce, recycle, reuse. There is another R. I think it's refuse. So, you can for the industrialization, whatever waste is generating, we have to make sure that how we are if we can utilize that waste, if we can reduce it, recycle it. And then another is about the what recycle, recovery. Oh, sorry, yeah, recovery. Yeah, that's the term. So recovery is that whatever waste from the waste, what we can get back and utilize. Reduce, that whatever we have, what how much this waste can be reduced. Recycle whatever we can recycle and again use in the industry. And reuse uh, the waste. Sluggish approach is simple, that people are ignorant. They think that it's not their job to save the environment, to make better decisions. So all of this is discussed, that all of this leads to the genesis of this subject. Now the last question is about the cation exchange capacity. So in the first lecture, or if you have seen the week 0 assignment, there's a question about the cation exchange capacity of soil. So it is that how much positive or the positive ions can a soil retain or hold, is about the is the cation exchange capacity of the soil. So the question is on what it depends. So first is the specific surface area. So surface area, it is the total surface area that is contained in 1 unit mass of soil. So why it is important? Because uh, the higher the surface, the specific surface area, the more is water holding capacity. So water holding capacity, or you can say the more number of pores. So how cation exchange capacity function is that we have cations and anions in a soil. Now if the higher the number of anion or negative charge, wait, higher, so higher the number of negative charge, the more positive charge it can store. So and another thing is about the type of cation. So the charge on the cation, is it 1 plus or is it 2 plus? So for example, for 10 Ca2 plus, if 10 Ca2 plus are removed from the system, they can take 20 K plus because of the charge. So the charge matters. It means the oxidation state of cation matters. The number or the amount of anion matters. Another thing is pores. If there are more pore space, these extra cations can fill those pore space. So uh, hence the specific surface area helps in more storage of the cation or the incoming cations. Another is type of cation. Definitely, as I said that depending on the oxidation state, the cation exchange capacity differ. So if you if a Mg2 plus has to replace it, only 10 Mg2 plus can replace a Ca2 plus. Another is surface feature. So pores are one surface feature. Another is uh, for example organic mass. So any soil which has high organic mass or has high clay content, they are actually a better cation, they have better cation exchange capacity. Why? Because if you look at clay, they are basically have these anion zone, they have high anion negative charge or high concentration of anions. So the more anions, or for example sulfate, ammonia, sulfate, nitrate, the more anions there are, they they attract or they want to dissolve more cation to neutralize the soil, right? To neutralize itself. So any soil with high organic mass content or high clay content has a better exchange capacity. So uh, the type of content matters. Surface feature, as I said, the pores, if there is any adsorption site on it, so on the soil, again it will help in the cation exchange capacity. So all of these features are important uh, for a soil to get more cations. So for today, uh, I have done for today the session is done. If you have anything else you want to ask, you can ask from the week 2 lectures if you have anything.